This section's on 6.2, systems of equations in three variables. So in this case, we're going to solve for x, y, and z. That's why it's called three variables. So similar to 6.1, in 6.1 though, we have two variables and we have three different methods. So in 6.2, because we have three variables, normally we only use two methods, and the two methods are the elimination method and then the substitution method. So you want to definitely do is go ahead and try to eliminate something first, and then if you can, substitute it at the end. So that way you just deal with just numbers, okay? So you will have now is three equations and three variables. So it does get a little confusing, so you have to be very organized on this. So what I normally do is then I go ahead and label this equation 1, equation 2, and then equation 3. So that way when I manipulate it, I know exactly which equation I use. So make sure you also label it. Now, the goal of this is to eliminate something, as we learned in the last section. So we have to either eliminate all the x's, so that way then you have, once you eliminate all the x's, then you just have either the y's or the z's as the second part of the elimination and working with, or you can eliminate all the y's, or you can eliminate all the z's. So whichever one you want to eliminate first, the variable, that's probably your goal. Step number 1 is to try to figure out which variable you want to eliminate. And then from there, once you eliminate the whole variable, then you have two other variables to work with. So you kind of have to work at little pieces at a time. Now, I'm going to go ahead and do variable for the z, just because this is already a 3, this is already a 3. So this, I can make it into a 3 easy enough, right? If I just multiply everything out by 3, like we did in the last section. So I'm going to go ahead and do that. So let's take these two right here, and this is also a minus, and this is a minus, and this is a plus. So what I'm going to try to do is I'm going to do a combination of this variable right here, or the two equations right there. We're going to work on those two right there, and then we're also going to go 1 and 3 as well. So in this system of equations with three variables, you can work with more than one equations, but you just obviously can't work with itself again, okay? So what does that look like then? So let's go ahead and take equation 1. So I'm going to go ahead and put 1 right here just to remind myself I'm working on equation 1. I'm going to write it as x minus 2y plus 3z, right, is equal to 11. And then we're going to go ahead and put the second equation. So second equation is 4x plus 2y minus 3z is equal to 4. And then, so our goal again was to eliminate the z. So since this is a plus and this is a minus, the operation we're going to use is a plus out here. Okay? So if you do a minus out here, what's going to cause a problem because it's going to go minus, minus. So that's going to become a plus right there. So because of that, you don't want to do a minus out there. You just want to keep it as a plus. So when you do that, this cancels out right there. So then I have as a coefficient of 1 right here. So it's 1 plus 4, that's 5x. And then I have as negative 2 plus 2. So here we have a problem because actually this cancels out right there. Okay? Then I have then as this cancels out, so then I have is 11 plus 4, which gives me 15. And so actually this is solved as x equals 3 right away. So this is already solved for. So now I have one variable down, so I just need is two variables, the y and the z. So I'm going to leave this for right now. Normally it doesn't happen this way, but let's go ahead and leave that for alone right now. And let's go ahead and then work on equations 2. Let's see, I did 1 and 2 right here. So let's go 1 and 3 now, that combination. Okay, so then I'm going to go ahead and put again equation number 1 right here. And so the one equation was x minus 2y plus 3z is equal to 11. And equation number 3 was 3x plus 3y minus z is equal to 4. And this is the one we wanted to change this right here, the z right here, to a 3. So I'm going to multiply everything through with a 3. So that's going to give me then 9x, right, plus 9y minus 3z is equal to 12. And then we just copy this top part right here. So this is just copying it as x minus 2y plus 3z is equal to 11. So now the operation we're going to put out here, since this is a plus and this is a minus, I'm going to go ahead and do a plus out here. Okay, so then that cancels out. So then I have is 1 plus 9 is going to give me 10. Then I have negative 2 plus a 9, so that's going to give me plus 7y, right, is equal to, and then I have 11 plus 12 is 23, right? So then from here, I'm going to call this equation A. Because what happened was it didn't eliminate anything else like we did with this first part right here. On this last equation right here, everything eliminated and I had this. But in this equation, I have is now an x and a y and a 23. Oh, but I have an x right here, right? So since I have an x, I can technically substitute this x into here, and then I can solve for his y right there. Okay, so let's go ahead and do that. So then we have is 10, and then the x is 3, plus 7y is equal to 23. So that's going to give me 7y is equal to 23 minus 30, right? Because 10 times 3 is 30. So 7y is equal to a negative 7. And so y is equal to negative 1. So we're getting closer because, again, our goal is to solve for x, y, and z. So I have an x, I have a y. Now I just need as a z. So when you have two variables already like that, you want to go back to the original up here and probably substitute it into either all of equation 1, all of equation 2, or equation 3. Either one, it doesn't matter, it works. So I'm going to just go with 1 just because 1 is the smaller one. So I'm going to copy the equation as x minus 2y plus 3z is equal to 11. And so we said 3 is the x and y was negative 1. So negative 1 plus 3z, right? Can you see that? Then we're just going to solve for z. Because this turns into a number, this turns into a number, so we just have a z variable. So then I have is 3 plus 2 plus 3z is equal to 11. So 3z is equal to 11 minus 5, right? Because 3 plus 2 is 5. So then 3z is equal to 11 minus 5 is what, 6? And so z is equal to 2 as the final answer right there. Okay, so like we did on the last section, we still have to write it in coordinate form. So we then have is kind of like different this way. I have is an x, a y, and a z right here. So the x number we said was a 3, a y is negative 1, and z is 2. So that becomes my final answer in this case right here. Okay? So there's a couple of ways to do this. I mean, you could have taken any other combinations, or you could have eliminated, probably you could even eliminate the y. The only thing is with the y, because I have 2's right here and a 3, you may have to go with 6 as the lowest common multiples right there. So which is fine. Then you would multiply everything out by 2 on the top, 3, everything on this second equation by 3, everything on the third equation by a 2, so you could have done it that way and manipulated and got rid of this right here and try to solve for x or the y or the z. And then you could have done also the x right there. So the lowest common multiples between 4 and 3 is 12, so you would have to get a 12 over here. So you would multiply everything on the top by a 12, this is by a 3, this is by a 4, and then from there again, try to eliminate this by combination. So you would do 1 and 2 combination, 3 and, either you could have done a 3 and 2 or 3 and a 1 combination. I mean, there's a couple of combinations to do this. There is no like necessarily wrong way, unless once you start getting into the substitution, because you can't substitute it into itself too many times. So other than that, they're just, you're going to have to be organized and make sure. I would always put is the numbers on the equation right here and then work it out right here, writing the equation so you know what you used, and what you could also do is the different combinations for that. Okay, so try this out now.